To get us started, let's do a problem of the day. And it says we're going to multiply, good old algebra today. Multiply into parentheses, we got 3x minus 4 times another parenthesis, 2x plus 5, combining like terms when appropriate. Folks, we call those two things binomials because they're two-termed expressions. So we're going to multiply two binomials together. And it says combining like terms when appropriate. We don't want to get too carried away and have things that aren't supposed to come together. So let's take a look at this problem and work it out a couple of ways. I like to use distributive property, and I like it because students seem to know what it is and how to work with it. But I want to rewrite the problem down here while y'all are writing it at home or in school, wherever you might be watching this problem of the day presentation. We've got 3x minus 4, one of our binomials, and we got 2x plus 5. So we've kind of thrown all sorts of different things at you here. And what we want to do is actually multiply these out. And to do that, we're going to use the distributive property, as I said. So first thing we're going to do, we're going to take the 3x and we're going to multiply it times this entire parenthesis. So I'm going to write that out for us because I think it's good to have, especially if you're first learning how to do this. So we're going to take 3x times 2x, but don't forget, we're also going to multiply it by the 5 there. All right, so we're going to have 2x plus 5 in a parenthesis, and we got a 3x on the outside here. What's going to happen? Oh, goodness things, all sorts of things. We're going to distribute again. I mean, we're going to basically run the distributive property. I just set it up for you. In just a second, we are going to distribute. Now, we don't want to leave out our minus 4 here. It's come a long way to be in this problem. Yeah, right there it is. And it also needs to distribute through that 2x plus 5 parenthesis. So let's toss it in for good measure. And this is one of those points where you're going to watch your signs. You hear me say it all the time on Mathline. Today is going to be definitely one of those cases. You're going to watch those signs. Now, as we go along here, let's just start the distributive property working for us. We're going to take 3x times 2x, and we're going to, like I said, take that 3x times 5. We're not going beyond that because that's where the problem basically ends. That's where the parenthesis says stop. And then we'll pick up the minus 4 in just a second. But let's do the first one. 3x times 2x gives us 6x squared. Now, go back here to 3x times 5. That's where it made it to, was the 5. That's going to give us 15x. Now, notice I mentioned something about combine when like terms when they're appropriate. These have x's, but they're not. I repeat, not like terms, so don't combine here. Now, let's go on to the next point here. Let's take our negative 4 through what we need to do. And that's going to give me a negative 4 times 2x first. That's going to give me minus 8x. Again, I said watch your signs. This is where you really definitely want to watch your signs. And distribute one more time. How about it? Minus 20, because that's what 4 times 5 gives us. It's a negative 4 times 5. And that's going to give us a minus 20 there. So putting it together, now we're going to talk like terms. Now we're going to combine those like terms when appropriate in order to simplify our problem. Right there we have them. They're two x's without exponents. All right, so it's 15x minus 8x. That's the only thing that will come together. So we keep our 6x squared. They're their own kind out there. Now we're going to pick up and say, what is 15 minus 8? Well, that's easy, isn't it? We're going to get 7x. And last but not least, the minus 20. Now, I said that's the way you do it using the distributive property. By the way, 20 doesn't blend with 7x. Nor does 6x squared blend with 7x. You got to keep them separated when you've got these pluses and minuses going here. Back to one more important point. When you say 3x times 2x, everybody be sure you put x squared because we're saying x times x, which is not x plus x, that's x times x. That's going to give you that x squared business. So be careful that you don't leave that squared off. I have a lot of times students forget to do that, and then all of a sudden, oh, we've got three things that together. No, we don't. We got an x squared, stays alone. Then we got 15x minus 8x, which gives us that 7x. Now, I mentioned there's another option, and some of you may have heard the FOIL method. Probably most of you have if you're in an Algebra 1 class. Those of you who haven't done Algebra 1 yet, you're going like, wonder what that's about. Well, FOIL doesn't mean we're going to wrap it in aluminum foil or something like that. We're going to take our two binomials here. We're going to multiply them together, and we're going to come up with a method that allows us to get all the multiplications in without having to really show that distributive property. We're working the distributive property, but we are going to take them just basically as we see them. So again, the first thing we did Hint, first thing we did was 3x times 2x. Folks, that's our f part of FOIL. That's our first part of FOIL, the f. First terms in each binomial. The next one, oil, all right? So O goes out to the outer. Notice where I'm going. I'm taking 3x and 5. Basically, that's just what we did here, all right? It's basically 3x times 2x plus 5. The only thing is, I'm just going to show you where we're going. Now, we've got 6x squared when you multiply those two together. We've got 15x going out here. Now go I. I means the opposite of outer, so it's going to be inner. Take your innermost right here. That would be minus 8x. And then, oh, don't forget, we got a last. Oh, put an I there. Yes, Ernie, be sure you put an I there. And there's the last, which means the -4 and the 5. They're the last terms in both binomials. Put them together. Oh, the L almost got into me. And we're going to have minus 20. And look what happens. We've got that like term situation once again. So again, bring them together. It's appropriate. Plus 7x minus 20. I noticed Mark had gotten this right on Facebook. Maybe some others. Nathan, I think, got yesterday's right on the obtuse scaling, but I digress a little bit. But anyway, good job on you guys who got there to the end. And I'll tell you one thing, even more, I think it could be cool. You know 6x squared, you know 20 is going to be. So the only thing really difficult about this problem is adding these two things together. And it's really not that hard. Mental math. Just put that 15x in your brain, subtract 8x from it, write 7x. You could eliminate that step also. But I wanted to show you all the different ways. This one is long. This one's not as long. And boy, go from parentheses to answer quick and painless. So there's actually 3 ways, if you count the mental math part in your head, that you can get to the final answer and get it correct.